trying this again. That's fine. Okay, so the first thing that I wanted to mention is it's only worth 4 points, which means that that's a hint that something about this should be a relatively simple manipulation of concepts you already have. You want to look at your formula booklet, and we just did that. And so in your formula booklet, if you look, and here it tells you kind of, because it tells you that there's the roots of the equation, and you want to show this. And in your formula booklet, in topic 2, HL12, they tell you that the sum is equal to minus a n of n minus 1 over a of n, and the product is equal to minus 1 to the n,
a0 over a
a0 over a n. And as a reminder, a polynomial function is a function of this form, y equals, where n is your, a sub n is your lead coefficient, and n is your highest degree. And you keep on going like this until you get to your constant term, where x of 0, x to the power of 0 is 1, and a sub 0 will be your constant. So in a quadratic, where you have ax squared plus bx plus c equals 0, our a sub n, what's our highest degree for you?
highest degree is 2.
So a sub n is therefore, that's a, and a sub n minus 1 right there is going to be what? What's the second highest coefficient? What's x of n minus 1? What's the highest degree in this equation?
After 2 is
So
n.
the highest degree is 2. What's the next highest degree?
Is n.
Okay. So this right here is my lead coefficient.
Mm-hmm.
And this is an nth degree equation. This is a second degree equation. It's called a quadratic. Right? So my n right there is 2. My n minus 1 would be x to the 1. So the coefficient of n minus 1, in this case, is b. And my constant term, the one that we call it 8 sub 0, what is that here?
C.
It's c. That's the one that has x to the power of 0. Okay. Now that I have that, I can find the sum. So we're told that the roots are sine of x and cosine of x. So the sum, which is cos theta plus sine of theta, in this case, is going to equal this right here, minus b over a. And then the product, which means the multiplication, is going to equal, and here we're going to use this right here. So it's minus 1 to the n. What's our n? What's the degree of our equation?
It's 2.
It is 2. Good. This is our equation right here. Minus 1 to the 2. A sub 0 is c, we said. And a sub n is a. Now I'm going to try and isolate my terms. We're looking for b and c, right? Because we're looking to show that it's b squared is equal to a squared plus 2ac. So I want to find b on its own. So minus b is equal to a cosine theta plus sine of theta. B is equal to minus a cos theta plus sine of theta. Let's square b, because we want b squared. So b squared is equal to minus a cosine theta, sine of theta, squaring the whole thing. Minus a squared, cos theta. Oop. And this is equal, therefore, to a squared cos squared theta plus 2 cos theta sine theta plus sine squared theta, which again, a squared cosine squared plus sine squared equals 1. 1 plus 2 cosine theta sine of theta. Yep. This is equal to a squared plus 2a squared cos theta sine theta. We're getting closer. Now we've got the a squared, we've got the 2. We want to show that a squared cos theta somehow equals ac. So now can we solve for c? Using this part right here. C is equal to a cos theta sine theta. Therefore, b squared is equal to a squared plus 2a times a cos theta sine theta. We just showed this was c. Therefore, b squared equals a squared plus 2ac. And this is where we want it to end. Do you have a question? No? No questions?
No.